Like most sorting algorithms, the quicksort algorithm sorts an array of items in ascending order. There are numerous approaches to quicksort. This video will focus on one method. This approach selects the leftmost element of the array as the pivot. It then compares it against the last element in the array. If the pivot is less than the element it's being compared to, that element becomes the pivot and the left side is incremented. If the pivot is greater than the element it's being compared to, the index value of that element is incremented. This occurs until the left and the right sides meet. Once the values meet, the element where they met is said to be sorted. Left and right partitions are created and new pivot points are generated. This version of the quicksort algorithm will follow these rules. Pivot is on the left. The pivot is the selected element that the quicksort algorithm compares all other elements to. Pivot is compared with the right element. If the right element is larger, the values of the right element and the pivot are swapped. The right element becomes the new pivot and the left index is incremented. If the right element is smaller, the right index value is decremented. So that's if the pivot is on the left, we're going to follow these rules. Now, if the pivot is on the right, the pivot is compared with the left element. If the pivot value is larger, increment the left index value. Pretty simple. If the pivot value is smaller, the values of the left element and the pivot are swapped. The left element becomes the new pivot and the right index is decremented. Now we get to the point where the pivot, the left and the right all point to the same element. That element is now sorted. Create the left and right partitions, set new pivot, left and right for both partitions, starting with the left, and then repeat the above procedure. So all of these things. So this is only one way to do the quicksort algorithm, and we'll start off with this example. The left element and index 0 is set as the pivot value and the right element is set as the last element in the array. The pivot value is compared to the right element. Since the right value is less than the pivot value, the right value is swapped with the pivot and the right value becomes the new pivot value. The left index is incremented. So next, the new pivot value is compared to the value at index 1. Since the pivot is greater than the left value, the pivot remains in the current position and the left element is incremented. The quicksort algorithm compares the pivot to the left. Since the pivot value is not greater than the left value, the pivot value is swapped with the left value. Index 2 becomes the new pivot and the right index is decremented. Next, the new pivot at index 2 is compared with the value at index 4. Since 5 is not less than 3, the values are swapped and the left index value is incremented. The quicksort algorithm compares the pivot value to the left value. Since the pivot value is larger than the left value, the left index is incremented. Now, both the left and the right arrows point to the same element. The algorithm knows that this value is sorted. Left and right partitions are created. The algorithm starts working on the left partition. The value at index 0 becomes the new pivot. The left arrow points to the pivot value and the right arrow points to the last element in the left partition. The pivot value is compared to the right value. Since the pivot is larger than the right value, the two values are swapped. Index 3 becomes the new pivot and the left value is incremented. The algorithm compares the pivot value to the value at index 1. Since the pivot value is larger, the left index value is incremented. The algorithm compares the pivot value to the value at index 2. Since the pivot value is larger, the left index value is incremented. So I hope you guys can see just how common sense this is. So if the pivot is on the right, and we're comparing it to something on the left, if the pivot is smaller than something on the left, well, it's got to go over here because we're trying to sort this stuff. And basically the opposite is true over here. So if the pivot is on the left and we're comparing to something on the right, and the pivot is larger on the left than something on the right, the two values are swapped. Let's go ahead and continue on. The algorithm compares the pivot value to the value at index 2. Since the pivot value is larger, the left index value is incremented. The left and right arrows have met at the same element. The quicksort algorithm now knows that the value at index 3 is sorted. New partitions are created, and since there is no unsorted value to the right of the pivot, only the left partition is created. So this is, again, a new left partition. whereas the one over here is the old right partition that was created when we created the left and right partitions at index 4. So the algorithm starts working on the left partition since it's still within the old left partition. It assigns index 0 as the pivot value and points the left arrow to it. The right arrow points to the last element within the new left partition. The algorithm starts by comparing the pivot value to the right value. Since the pivot value is less than the right value, the right index is decremented. Next, the value at indices 0 and 1 are compared. Since the pivot value is smaller, the right value is decremented again. And now the left and right arrows have met at index 0. The quicksort algorithm knows that the value at index 0 is now sorted. New partitions are created. Since there is no value to the left of the pivot, only the right partition is created. Since the algorithm is still within the left partition, so remember when we split it here, this is the old left partition right here. It starts working on the new right partition. So this is the new right partition within the old left partition, the first left partition, I guess we should call it. The reason why I'm saying this is because we keep going deeper and deeper, and you may be wondering why we're not working on this old right partition. Well, we're recursively trying to get all this stuff sorted, so up until we get all of this sorted in the left array, we're not going to be moving to the right array. The pivot and the left arrow both point to index 1. The right arrow points to index 2. The values at indices 1 and 2 are compared. Since the pivot value is less than the right value, the right index is decremented. The left and right arrows have met at index 1. The algorithm knows that the value at index 1 is sorted. New partitions are created. Since there are no unsorted elements to the left of index 1 within this partition, only the right partition is created. Since the quicksort algorithm is still within the left partition, it starts working on the new right partition. It points the pivot, a left arrow and right arrow at index 2, since that is the only element in this partition. The arrows have met at index 2, so the algorithm knows that the value at index 2 is now sorted. The quicksort algorithm has finally made its way out of the first left partition and starts working on the right partition. It points the pivot, a left arrow and right arrow to the only element available. Since both arrows point to the same element, the algorithm concludes that the value at index 5 is now sorted. Since there are no other partitions to sort, the quicksort algorithm ends. This is a difficult one for most people to understand. If you didn't understand it the first time, I'm confident that you'll get it on the second or third attempt. See you guys in the next video.